Hello, algebra students. Mr. Lawrence here, and this is the final review for Chapter 7 video. All right, I got to tell you, I had like 8 billion kids in for help today. I'm very glad to see. We even had some of second period represented. That was good. There was at least 2 or 3 kids from second period. All right, very good. So let's get down to this so the video doesn't take too long. Chapter 7 is pretty easy. It's all about exponents and exponential growth and decay and all that kind of stuff. All right, so first of all, you need to remember what a zero exponent means. Any non-zero number raised to the 0 power equals 1. So you see problem C here, 7 to the 0 power, that is 1. Okay, negative 5 to the 0 power is going to be 1. Now, if I do negative 5 to the 0 power, that's going to be negative 1, right? You gotta, because the parentheses matter. But it works for any non-zero number. So be careful. If I gave you this, this would be undefined. You cannot do that. All right, now, a negative exponent means to use the reciprocal. So 5 to the negative second power is really easy. You do 5 to the second power, which is 25. 5 to the negative second power is 1 over 25, right? 3 to the negative third, I'm going to do 3 to the third, which is 27. 3 to the negative third is going to be 1 over 27. Do you notice there are no negatives in my answers? No, there's not. A negative exponent is not multiplication. You don't multiply by a negative. Did you hear that? You're not multiplying by a negative. You're raising 3 to the third power, and then you're using the reciprocal. All right, if I had something like this, to the negative second, well, I would do 5 halves to the second, which would get me 25 fourths. This one has to be the reciprocal of that, so the answer is going to be 4 25ths. Yeah, pretty simple stuff. All right, we can simplify things with exponents, right? Negative exponents mean to use the reciprocal. So this x to the negative first here on problem D is going to move to the numerator. The y to the negative second is going to move to the denominator, negative seventh, excuse me, and these are just going to simplify. So let me try simplifying here. So let's see, 20 60ths is going to simplify to 1/3, I believe, right? Yeah, that'll be 1/3. Now I'm going to have an x to the sixth times an x to the first. When I move that x to the negative first to the numerator, the exponent becomes positive. In the denominator, I'm going to have a y to the second times a y to the seventh. And then we have a z to the fourth over z to the 10th. Neither of those are moving. All right, so now I'm going to simplify as best I can. So let's see, I'm still going to have a 1/3. All right, x to the 7th power, right? X to the 6th times x to the first is x to the 7th. Denominator is going to have a 3. It's going to have a y to the 9th. Now what's going to happen with the z's? Well, there's going to be 4 z's in the numerator. 1, 2, 3, 4. There's going to be 10 z's in the denominator. And then some of them are going to cancel out, right? There's going to be 6 z's being multiplied left over. Where are the leftovers? In the denominator. Z to the 6th. So the best answer, the simplest answer, if you put the 1 there, I won't mark off, but the simplest answer would be this. 3y to the 9th, z to the 6th. And there you go. All right. So how about problem E? If you want, if you feel good about it, pause the video, try problem E on your own. If you need to see me do it, I'm going to go ahead and do it. All right, here we go. Are you ready? First, I'm going to work inside the parentheses. I'm going to simplify it as much as possible. I'm going to simplify 4/6 down to 2/3. I'm going to take care of these negative exponents. The x to the negative third is moving to the denominator, right? The z's are going to switch places. The z to the negative 6th will go to the denominator. The z to the negative 11th will go to the numerator. I'm not going to worry about that negative 2 outside yet. I'm going to simplify everything as best I can, and then I'll worry about the negative 2. So my new fraction, or the new look at my fraction, is going to have a 2. There's going to be a 3. Now I know the x to the negative 3rd is moving down, so I'm going to have an x to the 7th in the denominator, right? Because it'll be x to the 3rd times x to the 4th. My y's, I've got y to the 5th over y to the 2nd. There's 5 y's in the numerator being multiplied, 2 y's in the denominator being multiplied. 2 of them are going to cancel. There's going to be 3 y's being multiplied left over, y times y times y, or y to the 3rd. And where are the leftovers? They're in the numerator. So y to the 3rd in the numerator. The z's are changing places, so they're going to look like this, right? When I cancel out, how many z's are going to be left over? 5. Or z to the 5th, where they're going to be in the numerator. Now, this is all raised to the negative 2nd power. So, I'm going to get rid of that negative exponent. How am I going to do that? I'm going to use the reciprocal. So this is going to be the same as 3x to the 7th over 2y cubed z to the 5th. My 3's look really bad. Jarrett calls this my world famous airliner. All right. So I'm going to have y cubed, I think I said, right? There we go. That looks better. And that will be raised to the positive 2nd power now. Hold on. Sorry about that. All right. So now I'm going to square everything. 3 squared is 9. X to the 7th times x to the 7th is x to the 14th. 2 squared is 4. Y cubed times y cubed is y to the 6th. And z to the 5th times z to the 5th is z to the 10th. And there you go. There it is. All right, next type of problems you need to know how to do, and we've already just done them, multiplying and dividing and powers raised to powers. When we multiply like bases, we just add the exponents. You might have noticed that on the last problem I was doing. I was adding exponents. When we divide like bases, we subtract the exponents. So take a look at problem A. And again, if you want to pause the video and try it on your own, go ahead. Here comes my answer. You know what? Before I do anything, I'm going to slide a 1 right there for that x. And now I'm going to multiply 3 times 5 and get 15. X cubed times x is going to be x to the 4th. And then y squared times y to the 4th is going to be a y to the 6th power. For division, I'm going to subtract the exponents. So I'm going to do 20 divided by 5, which is 4. Hey, Mr. Lawrence, you just said you were going to subtract. No, I did not. I said I was going to subtract exponents, not 20 divided by 5. 20 divided by 5 isn't 15. When we took the test on this, somebody tried to tell me that. Think about what you're doing. It doesn't make any sense. If you'd rather rewrite this as a division problem, you could write it as 20x to the 6th, y to the 4th, over 5x to the 4th, y to the 7th. You could do it that way. You'll get the right answer. I'm not going to. I'm going to show you this way, but it's not wrong to do it that way. X to the 6th divided by x to the 4th. Well, I think there's going to be 2 x's left over after they cancel. I'll have an x squared. Now this one's tricky. I'm going to get a y to the 4th divided by a y to the 7th. Subtracting exponent is going to get me y to the negative 3rd. But a negative exponent means to use the reciprocal. So I'm going to have a 4x squared, and that's going to be over y cubed. Why? Because I used the reciprocal. All right, now C is the type some people get screwed up, and it's super easy. Just think about what this means. This 2 here means there's 2 of these. So in other words, it's 2 to the 4th times 2 to the 4th. That's the same as 2 to the 8th. Yeah, and 2 to the 8th, let me see, 2 to the 5th, 32, 64, 128, 256 should be the answer. 256. D means there's 3 of these. So in other words, x to the 7th times x to the 7th times x to the 7th. Well, that's going to be x to the 21st power. All right, this one here is easy because the negative means to use the reciprocal. So I'm going to use the reciprocal. I'm going to use 1 over the quantity of x squared, y to the 4th, z squared. But that's still cubed, right? So now I'm going to have 1 over x to the 6th cubed, well, x to the 2nd cubed, excuse me, which would be x to the 6th. Y to the 4th cubed, I think that's going to be y to the 12th. And z squared cubed will be z to the 6th. Now, in case you didn't realize it, the shortcut for a power is to raise to a power is to multiply the powers. Yeah, if I have to do x to the 15th raised to the 3rd, that does equal x to the 45th. When I'm just multiplying, I add the exponents. When I'm doing a power raised to a power, I multiply the exponents. All right, so moving right along. Converting exponential form to radical form and radical form to exponential form. All right, look at problem A here. Remember, the top number is an exponent, is a power. The bottom number is a root. What's being raised to the 2/3 power? The 12? No, the A. So I'm going to have a 12, and then I'm going to need a root. What root am I going to need? Well, I'm going to need the cubed root, because the denominator tells me the root. And that's going to be an a squared inside the cubed root. And that's all you can do. Now this one's a little bit different. I could put the whole thing under the 5th root. This is one way to do it, but I do not want to do it this way. Okay? Because this can be simplified. I'm going to think about this 64 as 32 times 2a. I'm going to raise that to the 4/5 power. Then I'm going to break it up into 2 pieces. I'm going to go 32 to the 4/5 power multiplied by 2a to the 4/5 power. So now I'm going to take the 5th root of 32, which I happen to know is 2, and I'm going to raise 2 to the 4th power. So this is going to be 16. Now this part over here, I can't take the 5th root of 2a, so I'm going to need the 5th root symbol, and there's going to be 2a to the 4th. Now I'm going to go ahead and simplify that a little bit more. And so I'm going to get 16 to the 5th root of 16 times a to the 4th. And there you go. All right, now to go the other way from radical form to exponent form, roots become denominators. So see this 5th root of b cubed? That's the same as b to the 3/5 power. Yeah. Now d's a little bit different because I can take the cubed root of 27 and I can take cubed root of d to the 5th. Maybe I'll break it up into 2 problems. I'll do the cubed root of 27 and I'm going to do the cubed root of d to the 5th. Well, the cubed root of 27 is 3. This I can think of as d times d times d times d squared. Well, these 3 can come out. So I'm going to have 3d times the quantity of d to the 2/3 power. So the 2 is from there, the square, and the 3 is from the root. But I can take this even one step further. I'm going to have 3d to the 1st times d to the 2/3. I can add the exponents. So I'm going to have 3d to the 5/3 power. And there you go. All right, if you want to ask more about that in class, you go ahead and do that. All right, finally, exponential growth and decay. And remember, your formula is A equals P times the quantity of 1 plus or minus R divided by N to the power of Tn. Remember, T in this context is time in years, not time in seconds, time in years. Time in years. N is the number of compoundings per year, right? So if it's compounded once, N is 1. They don't mention compounding. You can assume it's compounded only once. It's the number of compoundings. Excuse me, it's been a long day. All right, R is the rate, the growth rate as a decimal. That's the rate. The plus is for increasing. The minus is for decreasing. P is the principal, not the Mrs. Armentrout, but the principal, the initial amount you start with. And there you go. Okay, so Tom has $3,000 in the bank. What's that? That's the principal. That's P. In an account where he's receiving an interest rate of 4.5%. Remember, we want the rate as a decimal, so the rate is 0.45. You have to divide by 100. Compounded every 4 months. If I compound every 4 months, N is 3, because every 4 months would be 3 times a year. It's not 4. It's only happening 3 times a year. What will be the value of the account in 5 years? Well, then T is right there. So I'm just going to go to my formula. I'm going to go A equals, the principal is 3,000 times 1. It's growing, so it's going to be plus 45 thousandths divided by 3 to the power of 5 times 3. And so I'm just going to go ahead and make that a 15. And at this point, I can go to my graphing calculator. And let me see if I can hold all that in my short-term memory. I think I can. So let me clear this off and make it bigger. And looks like I got some parentheses there I don't want. So I'm going to go 3,000, 1 plus 0.045 divided by 3, right? Raised to the power of what? 15. And look at that. The account is worth $3,750.70 rounded up. There you go. All right, let's try one more, and then two more, and then I think we're done. Yeah. Okay. So, a town is losing people at a rate of 1.5% per year. If the town has 22,000 people today, approximately how many people will there be in 9 years? Let's see if we can go through and identify what everything is. Okay, so my rate should be 0.015, 15 1,000ths. 22,000 is my principal. 9 years is my time. N is 1 because it wasn't mentioned being compounded. Right, so A equals 22,000 times 1. It's losing people minus 0.015. I don't need to worry about dividing by 1 because it won't accomplish anything. And then I don't need to multiply 9 times 1. I'm just going to put 9. And now I can go to my calculator. So I'm going to have 22,000, 1 minus 0.015. And I'm going to raise that to the 9th power. And in 9 years, I would expect approximately 19,202 people, approximately. All right. Now, the last one says, how many people lived in the town 7 years ago? Well, that's the same problem, except T has changed. T, do you know? -7. So I'm going to do A equals 22,000 1 minus 0.015, 15/1000ths, to the negative 7th power. And this will go travel back in time and tell me approximately how many people were there. So I think I can just do a second enter, so I don't have to retype everything. Arrow up to the 9 and change it to a negative 7. And there we go. There were approximately 24,455 people. And I really like my answer because the number of people went up. There were more people in the past, right? Okay, let me just check and make sure that was the last one. I believe that was. Yep, there are no more pages to be found. So that's it for the Chapter 7 video. Mr. Lawrence signing off. Have a good night, everybody.